It started as just another quiet day at NASA's Jet Propulsion Laboratory in California. Scientists were busy with their usual tasks, analyzing data from distant stars, exploring the mysteries of black holes, and monitoring the countless objects floating through our solar system. But then, an unusual blip appeared on the screens, an asteroid unlike any they had ever seen before. If you found this video interesting, don't forget to hit that subscribe button to stay updated on all the latest updates and cosmic events. At first, it was a faint signal, a mirrored on the radar. But as the data poured in, the team grew silent. The object was massive, roughly the size of a 10-story building, hurtling toward Earth at an alarming speed. Calculations revealed the asteroid's closest approach would happen in just a few days. They named it Athena 999. The news was kept under wraps at first to avoid global panic. Behind closed doors, world leaders convened emergency meetings. NASA, ESA, and other space agencies collaborated on potential solutions, but time was not on their side. Athena 999 was no ordinary asteroid. Its surface composition suggested it was denser than most, with a core of metallic iron and nickel, making it nearly indestructible. What's worse, its trajectory wasn't just a near miss, it was on a direct collision course with Earth. As the hours ticked by, humanity's brightest minds worked tirelessly. Could they deflect it? Could they destroy it? Could they evacuate cities in its path? Every scenario seemed hopelessly inadequate. If you found this video interesting, don't forget to hit that subscribe button to stay updated on all the latest updates and cosmic events. Meanwhile, rumors began to leak. Social media buzzed with conspiracy theories. NASA is hiding something. The asteroid is a government hoax. Prepare for the apocalypse. On the streets, fear began to spread. Shelves in supermarkets emptied. Families packed their cars and fled cities, though no one knew where safety could be found. Finally, NASA held a press conference. Athena 999 is an extraordinary challenge, said Dr. Evelyn Grant, the lead scientist. We are exploring every option, and we will not stop fighting for humanity's survival. But even she knew the odds were slim. The asteroid's arrival was inevitable. As the final hours approached, an eerie calm settled over the world. Cities were silent, skies clear, and humanity seemed to hold its collective breath. Then, the unthinkable happened. High above Earth, just as Athena 999 came within striking distance, a mysterious flash of light illuminated the night sky. Satellites captured the moment as something, no one knows what, intervened. Athena 999 split into fragments, harmlessly burning up as they entered Earth's atmosphere. The world erupted in relief and celebration, but the question remained, what saved us? A secret government weapon? Alien intervention? Or was it sheer luck? Humanity had survived this time, but one thing was certain, Athena 999 was a wake-up call. The silent giants lurking in the void of space were real, and the next one might not be so forgiving. If you found this video interesting, don't forget to hit that subscribe button to stay updated on all the latest updates and cosmic events. From the depths of space comes an unexpected visitor. A giant asteroid, 2024 XN1, is heading towards Earth. NASA and the European Space Agency have confirmed its approach. But how close will it come? What would happen if it collided with our planet? And are we truly prepared for such cosmic threats? 2024 XN1 is set to pass Earth at a distance of 7.21 million kilometers. To put that into perspective, that's about 18 times the distance between Earth and the Moon. While that may sound far, in cosmic terms, it's considered a close approach. NASA and ESA have assured the public that there's no risk of collision this time, but the asteroid's sheer size has raised eyebrows. Measuring the equivalent of a 10-story building, 2024 XN1 could cause unimaginable destruction if it ever did strike Earth. If you found this video interesting, don't forget to hit that subscribe button to stay updated on all the latest updates and cosmic events. Let's dive into a terrifying what-if scenario. According to scientists, if 2024 XN1 were to collide with Earth, the impact would release energy equivalent to 12 million tons of TNT. To put it simply, it would obliterate an area of approximately 2,000 square kilometers. This would be akin to the infamous Tunguska event of 1908, where an explosion in Siberia flattened 80 million trees across a massive area. Such an impact today could destroy a major city, disrupt the climate, and cause catastrophic global consequences. While 2024 XN1 will safely pass us this time, scientists warn of closer encounters in the future. In 2032, it's expected to pass at a distance of just 4.7 million kilometers, and by 2106, that distance could shrink to 3.4 million kilometers. Though these distances still seem vast, they underline the unpredictable nature of near-Earth objects. Could this asteroid, or others like it, pose a greater threat as their trajectories evolve over time? This is the question that keeps astronomers vigilant. This close call serves as a reminder of humanity's vulnerability in the face of cosmic dangers. Fortunately, NASA and ESA are working on planetary defense systems to protect Earth. In 2022, NASA's DART mission successfully altered the trajectory of a small asteroid, a groundbreaking achievement in planetary defense. However, larger asteroids like 2024 XN1 would require far more advanced technology to deflect or destroy. This highlights the urgent need for continued investment in asteroid detection and mitigation strategies. Asteroids like 2024 XN1 remind us how fragile our existence is on this pale blue dot. Earth has faced cosmic impacts throughout its history, some of which have caused mass extinctions. But now, for the first time in history, humanity has the technology to protect itself. The question is, are we doing enough? With billions of dollars spent on space exploration and defense, are we prepared for the day when a silent giant like 2024 XN1 takes a more dangerous path? If you found this video interesting, don't forget to hit that subscribe button to stay updated on all the latest updates and cosmic events. 2024 XN1's passing is both a window into the mysteries of space and a wake-up call for humanity. While this asteroid poses no immediate threat, it serves as a stark reminder that we are not immune to cosmic events. As we look to the future, it's clear that our ability to detect and defend against these silent giants is critical to the survival of our planet. What do you think? Are we ready to face these threats, or is there still much work to be done? Let us know your thoughts in the comments below. Until next time, stay curious and stay safe. The universe is vast, mysterious, and indifferent. But from the dark void, a new threat has emerged, an asteroid unlike any we've ever seen before. Its name, 2024 XN1. It was a discovery that sent shockwaves through the world's space agencies. It was fast approaching, its trajectory seemingly certain to bring it into the orbit of Earth itself. The question wasn't if it would pass by, but how dangerously close it would get. NASA, in collaboration with the European Space Agency, quickly issued a warning. At 7.21 million kilometers away, 2024 XN1 would pass closer to Earth than any known asteroid of its size, by a wide margin. In comparison, that's roughly 18 times the distance between Earth and the Moon. While that might sound far, the word close took on a terrifying new meaning. The asteroid, roughly the size of a 10-story building, was on a direct path, and no one could predict with absolute certainty where it might land if things went wrong. For a time, the world watched in a mixture of awe and disbelief as scientists, engineers, and astronomers scrambled to track the asteroid's path. But one thing was certain: the real danger lay in what might happen if Earth weren't as lucky as it seemed. If 2024 XN1 were to collide with Earth, the catastrophic consequences would be beyond imagination. Imagine this. The impact would release energy equivalent to 12 million tons of TNT, an explosion so powerful that it could obliterate over 2,000 square kilometers of land, flattening entire cities in an instant. The explosion would send shockwaves across the planet, turning vast areas into wastelands, and the climate could be irreparably altered for years. An event like this would rival the Tunguska disaster of 1908, a massive explosion that flattened 80 million trees in Siberia, but on a far grander, deadlier scale. The terrifying prospect of such an impact hung over the planet like a dark cloud. But there was hope, at least for now. Experts had ruled out the chance of a direct collision this time. The asteroid would sail past, safely, albeit closely. But could the same be said for future encounters? Scientists, armed with their advanced telescopes and prediction algorithms, calculated the trajectory of 2024 XN1, and it wasn't good news. They predicted that in 2032, the asteroid would pass at just 4.7 million kilometers away. And by 2106, the distance would shrink even further to 3.4 million kilometers. The situation was far from resolved, and the clock was ticking. What if the asteroid shifted course unexpectedly? What if a collision was inevitable in a few hundred years? The world's most brilliant minds were in a race against time. But how could they prepare for such an unimaginable threat? How could they stop something moving at incredible speeds from plunging into Earth? NASA, ESA, and other global space organizations had long been working on planetary defense technologies. The DART mission in 2022 had been a significant breakthrough, the first successful attempt to alter the path of an asteroid by crashing a spacecraft into it. But 2024 XN1 was far larger and faster than the test objects that had been targeted in these missions. Could any of humanity's current defense systems handle such a colossal threat? The more the experts worked, the more they realized that time was not their ally. The asteroid was coming, and its approach was a reminder of just how fragile life on Earth truly is. In this vast universe, we are but a speck, and our survival is tied to forces we can barely comprehend. Could we truly defend ourselves from cosmic threats, or were we, as a species, powerless in the face of such overwhelming odds? As the asteroid's passing grew nearer, the world held its breath. Governments, space agencies, and ordinary citizens alike were forced to confront the same uncomfortable truth. Humanity's future may depend on the actions taken in these final hours, and the survival of the planet may be just a matter of luck. But even as the countdown to 2024 XN1's passing continued, a deeper question emerged, one that no one had an answer to. Could our technology evolve fast enough to prevent disaster? Could we develop the systems to defend our planet from the next cosmic visitor? In the coming years, astronomers would track the movements of asteroids, hoping for a glimmer of hope. But the reality was clear. The dangers lurking in the depths of space were not isolated events. They were becoming more frequent, more imminent, and humanity's ability to survive depended on how well it prepared for the next giant to come barreling toward Earth. And so, as the world watched 2024 XN1 soar past, unharmed for now, scientists and engineers worked tirelessly to ensure that the next asteroid, and the one after that, would not be the end of us. For in the end, the greatest battle we face is not against each other, but against the vast, cold universe that surrounds us. The countdown to survival was ticking. Would we be ready when the next visitor arrived? As the days passed, the news cycle continued to buzz with updates, debates, and scientific analyses. In conference rooms around the world, teams of astronomers, physicists, and engineers were engaged in a frantic race. Time, as they all knew too well, was running out. In one such meeting at NASA's headquarters, the atmosphere was thick with tension. The room, filled with some of the most brilliant minds on the planet, was haunted by one question. What if the asteroid's trajectory had shifted? The calculations had been precise, the simulations meticulous. And yet, as the hours ticked by, uncertainty crept in. A slight wobble in 2024 XN1's path, an unpredicted gravitational pull, a new data anomaly, it could change everything. We're working with a window of less than 24 hours, said Dr. Emily Winters, the lead scientist heading the Planetary Defense Task Force. Even a tiny deviation in its course could push it into Earth's atmosphere. We can't afford to take chances. But in that room, no one had an answer. The asteroid was barreling closer at an alarming speed. If something went wrong, even with the most advanced technology available, there might not be enough time to stop it. The world would only have minutes, seconds, before catastrophe struck. Meanwhile, across the globe, in the heart of the European Space Agency's monitoring station, another team of scientists had just received an urgent transmission from an observatory in South Africa. They had spotted something that wasn't in the initial models. We're detecting a strange fluctuation, Dr. Alexander Ruiz, the ESA's chief astronomer, reported to his team. It's a minor gravitational anomaly near the asteroid's path. It might be nothing, or it might be something we need to monitor. We should alert NASA. Minutes turned into hours as the ESA and NASA teams collaborated. The anomaly appeared insignificant at first, but as their simulations began to converge, the horrifying reality became clear. The asteroid's course was indeed shifting, slowly but steadily. The gravitational anomaly was too large to ignore, and it was taking the asteroid closer to Earth. Back in Washington, D.C., President Claire Andrews was briefed by her team in the Oval Office. The room was filled with an air of grim seriousness, each advisor quietly contemplating the magnitude of the situation. Are we looking at a direct impact? The president asked, her voice steady but laced with tension. Not yet, Madam President. But the asteroid's new trajectory brings it dangerously close to our atmosphere, General James Wallace replied, his expression grim. We estimate that if nothing is done, it could pass within 2 million kilometers. That's an impact zone we can't ignore. The question is, what can we do? Dr. Winters, now on a secure video call from NASA's command center, spoke up. We've analyzed the situation, and our team is preparing for an emergency deflection operation. But there's one major issue. We don't have the resources to implement it in time. We need immediate global cooperation. The president's eyes narrowed as she took in the weight of the news. In her mind, the looming catastrophe wasn't a matter of if, but when. And the clock was ticking. There was no turning back now. As the night stretched on, the world's leaders convened in an unprecedented emergency session, bringing together heads of state, scientists, military leaders, and engineers. Global resources were mobilized as never before. Satellites were repurposed for a last-ditch effort to alter the asteroid's trajectory. Despite the unprecedented efforts, there was a growing sense of dread in the air. All eyes turned to the DART mission's technology, humanity's first real attempt to deflect a large space object. But could it really work on an asteroid this massive? Could the technique that worked on small asteroids actually prevent the collision of 2024 XN1 with Earth? We need to try, or this will be the last attempt humanity ever makes, Dr. Winters said, her voice resolute. This asteroid is a giant, and our weapons are still small. But it's our only hope. In the final moments before the deflection mission launched, a sense of surreal silence washed over the world. People gathered around televisions and screens, eyes glued to the broadcasts of NASA's live feed. A single spacecraft, launched months earlier, would now rush toward 2024 XN1, armed with nothing more than sheer human ingenuity and hope. As the spacecraft approached, the countdown began. 1 minute, 30 seconds, 15. The world held its breath. Seconds before impact, however, something unexpected occurred. The asteroid began to pulse, almost as if it were responding. A strange energy surge radiated from its surface, sending shockwaves through the ship's communication systems. Wait, what's happening? Dr. Winters shouted, her face ghostly pale as the screens around her flickered and data surged on their own. But it was too late. The last thing she saw was the spacecraft veering off course, struck by an unknown force. The signal was lost. The asteroid continued its approach, now only hours away. As the world faced the impossible, there was only one certainty left. Earth had never before been so vulnerable. And as the asteroid neared, the question that haunted every mind was no longer, will it hit? But when? The countdown had begun. Would humanity survive, or was the cosmic reckoning closer than we dared to imagine? With this turn of events, the narrative dives deeper into mystery and tension. The notion of the asteroid being influenced by an unknown force adds an element of suspense and fear of the unknown. The urgency and race against time intensify as humanity's best efforts seem to unravel, leaving the fate of Earth hanging in the balance. Will the mission succeed? Or is this just the beginning of something far worse lurking in the vast reaches of space?